Okay, this is another DocWatt quick video. Nothing fancy here, just a quick explanation of some ideas that people had some questions about. We're going to look at the idea of a permutation. Permutations are a way of counting some things. The things that we're counting are the number of things that we can collect from a group that have a certain property. A presidency is a good way to think of as a good example of a permutation. Suppose that we had a group of 5 people. For right now, let's call them A, B, C, D, and E. And from these 5, we want to choose a presidency of 3. So the properties here are that once we choose 3 people, one of them is going to be president, one of them's vice president, one of them's secretary, and the order that those are chosen in matters. Okay, that's the properties of a permutation. We want to know how many different presidencies we can select from this group of people. Now, I would suggest that you stop the video right now for just a couple of minutes and try writing down all of the presidencies that you can from those 5. Okay, if you took a minute and paused and tried to do that, you may have discovered that there were actually 60 different presidencies. That's kind of surprising. Out of these 5 people choosing a presidency of 3, a permutation of 3 things from 5 is going to be 60. Here's one way to think of it to try and do the counting. Suppose that we started out and picked the president first. Notice that there are 5 ways that we could do that. The president could either be A, B, C, D, or E. So there's at least 5 different presidencies. There are 5 different permutations. Once one of these are picked, maybe we pick C to be the president, then no matter which one we pick, there's only 4 that we can choose as the vice president, because we can't use the one that we picked as the president. But for any president that we pick, there's going to be at least 4 choices for the vice president. Once that vice president has been picked, there are only 3 choices left. In this case, if we had picked B to be the vice president, then all that's left in this particular choice, president, vice president, then I can't use C or B anymore, but I could either pick an A, D, or E for the secretary. So there'd be 3 choices for the secretary. Now, of course, completing this whole tree diagram would be kind of complicated, but you can see that there would be a total of 60 different choices for a presidency, choosing them from here. There are 6, the permutation, choosing from 5 things, choosing 3 is going to be 60. There's a notation for this. P for permutation, 5 out of 5, we're going to pick a permutation of 3. In this case, we know that that's equal to 60. Now, some notation is going to be kind of useful here. In mathematics, we use something called a factorial. For example, 5 factorial is equal to, this is just a shorthand notation. Somebody invented it because a lot of times they were doing this kind of multiplying, kind of counting down multiplying. 5 factorial is 5 times 4 times 3 times 2 times 1. So if you wanted another example, 2 factorial is going to be 2 times 1. You just count down from the whole number till you get to 1. Of course, 1 factorial is just going to be 1. And 0 factorial, for convenience sake in a lot of our formulas, we're going to define that as 1. Now notice that 0 factorial is defined to be 1. That means that we can write the general formula for the permutation, choosing n r things out of n of them, is going to be equal to this. It's going to be equal to n factorial. Now that's too much. See, if we had looked in this case and done 5 factorial, we'd have a 2 times 3 on here, which was too much. We need to kind of take off the part that we don't need, n minus r factorial. Okay, that's the general formula for a permutation. Notice that it works in our case. P5, 3 is equal to 5 factorial divided by 5 minus 3, that will be a 2 factorial. So this is going to be a 5 times 4 times 3 times 2 times 1, all divided by a 2 times 1, and sure enough, these cancel, and there's that 60 that we were looking at before. Okay, that's the idea of a presidency. Just one more quick note. Permutations can be written like this. That's a popular notation for it. Sometimes the notation is written like this. Okay, that's the end.